We assume that the velocity of water striking the wall normally. So on simplification, here acceleration is minus 6,000. The law of conservation of momentum is coming into picture. It undergoes retardation, alva. Its acceleration reduces. It is nothing but the average force acting on the bullet. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. My today's concentration is to solve numericals from the chapter Laws of Motion. Very interesting problems. Hope you have prepared with this session. You have gone through Newton's laws and you are all geared up to solve the numericals. The first one, students. Now, water ejects with a speed of 0.2 meter per second. Ejects. Ejects means to come out, to flow out. So water is ejecting with a speed of 0.2 meter per second through a pipe of area of cross section 1 into 10 power minus 2 meter square. So water ejects out, water flows out or comes out through a pipe whose area of cross section is 1 into 10 power minus 2 meter square. If the water strikes the wall normally, calculate the force on the wall. I have to calculate the force on the wall in Newton, assuming the velocity of water normal to the wall is 0 after collision. We assume that the velocity of water striking the wall normally is 0 after collision. Now, to begin with, volume of water which strikes the wall per second. So we will calculate the volume of water which strikes the wall per second is equal to 2 into 10 power minus 3 meter cube. So volume of water which is striking the wall per second is 2 into 10 power minus 3 meter cube. If so, then mass of water which strikes the wall per second. Volume calculate ಮಾಡಿದ್ದೀನಿ. I know density of water. So mass is volume into density. Alva? Because you know density is mass divided by volume. So mass is volume into density. So M is 2 into 10 power minus 3. Density of water is 1000 kg per meter cube. So this is nothing but 2 kg. So mass of water which strikes the wall per second is 2 kg. Now there should be some change of velocity, no? Before collision and after collision. Before, water can strike the wall, and after striking the wall, so change in velocity is 0.2 minus 0, which is 0.2 meter per second. This is the initial velocity. He clearly says after collision, after striking the wall, water is at rest. Final velocity is 0. So 0.2 meter per second. Therefore, students, here force is nothing but change in momentum. So this is M into V, 2 into 0.2, and therefore the answer is 0.4 Newton. So this is the force exerted by water on the wall. The next one, a gun of mass 5 tons. So this is the mass of the gun, 5 tons. And a bullet of mass 20 grams. So this is the mass of the bullet with a velocity of 110.2 meter per second. Find the velocity of the gun. So there is a gun whose mass is 5 tons. Mass is given in tons. And the mass of the bullet is 20 grams. It is fired with a velocity 110.2 meter per second. We have to find the velocity of the gun. Somewhere here, the law of conservation of momentum is coming into picture. The moment we say gun, the moment we say bullet, velocity of the gun, velocity of the bullet, conservation of momentum plays a very important role. Before firing, both the gun and the bullet are at rest, is it not? Before the bullet is shot from the gun, both the gun and the bullet are at rest. Therefore, initial momentum of the system. So, initial momentum of the system I call as Pi is 0. It is 0 because before the bullet is shot, both the gun and the bullet, they are at rest. Now, final momentum of the system, PF, is equal to M1V1 plus M2V2, where M1 is the mass of the gun, M2 mass of the bullet, V1 velocity of the gun, V2 velocity of the bullet. Now, from the conservation of momentum, M1V1 plus M2V2 should be 0. So this is nothing but from the law of conservation of momentum. I want V1. So M1V1 is minus M2V2, or V1 is minus M2V2 by M1. This is minus 20 into 10 power minus 3. So 5 into 1000, because 5 tons is the mass of the gun. So this turns out to be minus 0.44 meter per second. So this is the velocity of the gun. The next one, students, interesting one. A bullet of mass 0.01 kg. There is a bullet of mass 0.01 kg moving with a velocity 20 meter per second. The bullet is moving with a velocity 20 meter per second. Is just stopped by a block of earth 0.04 meter thick. Find the average force acting on the bullet. So by data, the mass of the bullet is 0.01 kg. And it moves with a velocity of 20 meter per second. U 20 meter per second. Now it is just stopped by a block. The bullet is brought to rest by a block. It is stopped, which means final velocity is 0. And what is the thickness of the wooden block? Yes, 0.04 meter. I have to calculate the average force acting on the bullet. Now, dear students, when the bullet is stopped by the block, it undergoes retardation, alva. Its acceleration reduces. So with all this data given, I will first calculate the retardation of the bullet, where we have V square is U square plus 2AS. I selected this equation of motion because the given problem does not contain the time parameter. So I had to select an equation which was independent of time. So 0 square equals, what was the initial velocity with which it was moving? 20 meter per second to 0.04. So on simplification, so this is 0.08A, or A turns out to be minus 5,000 meter per second square. So very clearly here, the negative sign is indicating retardation. Now I have calculated the retardation. I will have to calculate the force. So very easily now from Newton's second law, force is mass into acceleration. Mass of the bullet is 0.01 kg. Acceleration is 5 into 3. That negative sign simply shows it is retardation. So on substitution, we get the answer as 50 Newton. So the force acting on the bullet is 50 Newton. The next problem, very similar to the previous one. A bullet flying with a velocity of 50 meter per second hits a wooden block and penetrates through a distance of 0.2 meter before coming to rest. The mass of the bullet is 0.03 kg. Calculate the resistance offered by the block of the wood. Here, the moment they say resistance, it is nothing but the average force acting on the bullet. So here, initial velocity is 50 meter per second. Again, final velocity is 0. Mass 0.03 kg. And the thickness or distance 0.2 meter. Now, as we did in the previous case, first we calculate the retardation. So V square is U square plus 2AS. 0 square is 50 square plus 2. A, S is 0.2. So on simplification, here acceleration is minus 6,250 meter per second square. Again with this force, mass into acceleration into 250, which is roughly 187 Newton. So we have seen how using the basic ideas of laws of motion, I have solved the numericals. In my upcoming session, we will solve few more numericals from this chapter. Until then, have a nice time. Thank you.